Hello guys, welcome back to this channel. This is City Academy, and in today's video we are going to solve likely examinable questions on sequence and series. Now in this video we are going to focus more on questions on arithmetical progression, that is AP. Now consider that you have a sequence, say 1, 3, 5, 7, 9, 11 and so on. Now for any sequence, the first value is called the first term. So for this sequence we have A, that is the first term, to be 1. And then we can as well talk about the common difference. Now the common difference is the difference between any two consecutive terms. So to move from 1 to 3, we want to add 2. From 3 to 5, we add 2. And then from 5 to 7, we also add 2. So this is the common difference. Now common difference because the difference is the same and then it's common to any two consecutive terms. So here we have the common difference to be 2. Now we can as well talk about the general term or the nth term. Now the general term or the nth term is given by the expression un equals a plus, we have n minus 1 in a bracket multiplying d. Now for this particular sequence, we have A to be 1, that is the first term, and then we have the common difference to be 2. So we can find the general term or the formula that produces this sequence. So we have un equals, we have A to be 1 plus, we have n minus 1 multiplying d, which is 2. So we have 1 plus, now let's multiply 2 across. So we have 2 times n, that is 2n. And then we have 2 times negative 1, which is negative 2. Now 1 minus 2 is negative 1. And then we have plus 2n. So this is the general term or the formula that produces this sequence. So you can test these values using this formula. So using this formula, we know that the general term or the nth term of an AP is given by a plus, into brackets we have n minus 1 multiplying d. So the first term of an AP is equal to a. The second term of an AP is equal to a plus d. The third term is equal to a plus 2d. And the fourth term is equal to a plus 3d. So you can confirm these expressions using this formula. So now let's talk about the three main formulas we are going to consider when solving a question related to arithmetical progression. So the first one is the general term, that is un equals a plus, into brackets we have n minus 1 multiplying d. And then we also have Sn, that is the sum of the first n terms. Now you can use this formula especially if you have the first term, that is a, and then you also have the last term. Okay, so if you are given the first term and the last term, then you can use this formula to find the sum of the first n terms of an AP. Now for the third one, if you are given the first term and the common difference, you can as well find the sum of the first n terms of an AP. So basically these are the three main formulas we are going to consider when solving questions related to AP. Now let's move ahead and solve some questions. So for question number 1, we have the question: for an AP, if the fourth term, that is U4, is equal to 20 and the seventh term, that is U7, is equal to 32, then we are going to find A, that is the first term, D, that is the common difference, and then un, that is the general term. So first of all, let's write down the general term of an AP. So the general term of an AP, un, is equal to a plus, we have n minus 1 multiplying d. Now from the question we know that u4 is 20 and then u7 is 32. So using this formula, we have u4 equals a plus, now wherever you see n, we are going to replace that with 4. So we have 4 minus 1 times d. So u4 is equal to a plus, now 4 minus 1 is 3. So we have 3 times d, which is 3d. So u4 is equal to a plus 3d, and then u4 is equal to 20. So let's call this equation 1. Now let's do same for u7. So we have u7 equals a plus 7 minus 1 multiplying d, and then we have a plus 7 minus 1 is 6, so we have 6d, and then that is equal to 32. Let's call this equation 2. Now since we have two unknowns, which are a and then d, and then we also have two equations, we can find the value of a and d respectively. So we can use the elimination method to do away with a, so that we find the value of d, and then we can substitute the value of d in any of the two equations to find the value of a. So using the elimination method, we have equation 1 minus equation 2. Now equation 1 is a plus 3d equals 20 minus equation 2, that is a plus 6d equals 32. Now a minus a is 0, and then 3d minus 6d is equal to negative 3d, and then 20 minus 32 is negative 12. So we have negative 3d equals negative 12. We divide through by negative 3, and then we have d to be equal to 4. So we have the common difference to be 4. So now let's find the value of a. So we can use any of the equations, whether equation 1 or equation 2. So now let's use equation 1. So from equation 1, we have a plus 3d equals 20. Now don't forget that the value of d is equal to 4. So we have a plus 3 times 4 equals 20. So we have a plus, now 3 times 4 is 12. So we are going to transpose 12 to the right hand side, so that we have 20 minus 12, which is equal to 8. So the value of a is equal to 8. Now let's find un, that is the general term, or the formula that produces the sequence. Okay, so we know un equals a plus n minus 1 multiplying d. Now we have d to be 4, and then we have a to be 8. So let's substitute that into this equation. So we have 8 plus n minus 1 times d, which is 4. So we have 8 plus, now let's multiply the 4 across. So we have 4 times n, that is 4n, and then we have 4 times negative 1, which is negative 4. Now 8 minus 4 is 4, and then we have plus 4n. So un is equal to, now from here we can factor out 4. So we have 4 outside, and then we have 1 plus n inside the bracket. So the general term un is equal to 4 multiplying 1 plus n. Now let's solve the second example. Now for question number 2, if 7 times the 7th term of an AP is equal to 11 times the 11th term, show that the 18th term of the AP is 0. Now we know that the 7th term of an AP is written as u7. And then we also know that the 11th term of an AP is written as u11. Now from the question, 7 times the 7th term is equal to 11 times the 11th term. So this is written as 7 times the 7th term is equal to 11 times the 11th term. So this is very simple. You can write this. Now let's continue. Now if that is the case, then we have to show that the 18th term of the AP is 0. Now we know that the general term of an AP, that is UN, is equal to A plus n minus 1 multiplying D. So U7 will be equal to A plus 6D, okay, because you have 7 minus 1. Okay, let's call this equation 1. And then U11 will be equal to A plus 10D, okay, because 11 minus 1 is 10. Now let's multiply 7 by U7 and then 11 by U11. So we have 7 times A plus 6D, and that is equal to 11 times A plus 10D, okay, all from this equation. Let's say equation 3. Now let's multiply across. So we have 7 times A, which is 7A. We have 7 times 6, which is 42. And then we have D, and that is equal to, we have 11A plus 110D. So here we are going to transpose what's on the left hand side to the right hand side. So we are going to have 11A plus 110D minus 7A minus 42D. That's equal to 0. Now 11A minus 7A is 4A, and then 110D minus 42D is equal to 68D. Okay, so that is equal to 0. Now we can factor out 4. So we have 4 outside, and then we have A plus. Now 68 divided by 4 is equal to 17. So we have 17D, and that is equal to 0. Now we divide through by 4. We divide through by 4, and then we have A plus 17D is equal to 0. Now remember that the general term of an AP is equal to A plus n minus 1 times D. So the 18th term will be equal to A plus 18 minus 1 times D. So we have A plus 18 minus 1 is 17 times D. So this is the same as this, which means that U18 is equal to 0, hence the proof. Let's solve our last example. So for the last question, the sum of the first and second terms of an AP is 4, and the 10th term is 19. Now we are going to find the sum of the 5th and 6th term. So from the question, we know that the first and second terms of the AP is 4. So we know that U1 plus U2 is equal to 4. Now the general term is UN equals A plus n minus 1 times D. So we know that U1 is equal to A plus 1 minus 1 times D. Now 1 minus 1 is 0, so U1 is equal to A. And then U2 is also equal to A plus 2 minus 1 times D, which is equal to A plus 2 minus 1 is 1. So we have a plus d, that is u2. So a from u1 plus a plus d from u2 is equal to 4 from this equation. So we have 2a plus d equals 4. Now let's call this equation 2. Now from the question, we also realize that the 10th term is 19. So we have u10, which is equal to a plus 10 minus 1 times d. So we have a plus, now 10 minus 1 is 9, so 9d, and that is equal to 19 because the 10th term is equal to 19. So let's call this equation 3. Now because we have the coefficient of a for equation 2 to be 2, and then the coefficient of a for equation 3 to be 1, let's multiply equation 3 by 2 so that we have the coefficient of a for both equations to be 2. So we have equation 3 times 2. Okay, so that's going to be 2a plus, now 2 times 9 is 18. So we have 18d, and then 2 times 19 is 38. So this is equation 4. Let's call this equation 4. So now using elimination method, we have equation 2 minus equation 4. Okay, so let's write equation 2. So we have 2a plus d equals 4. That is equation 2. And then minus, we have 2a from equation 4 plus 18d equals 38. Now 2a minus 2a is 0. Okay, and then d minus 18d is negative 17d, and then 4 minus 38 is negative 34. Okay, so we divide through by negative 17, and then we have d to be 2. So the common difference, d, is equal to 2. Now let's find a, that is the first term. So we can use any of the two equations, that is equation 2 and then equation 4. We can as well use equation 3, any of them. So let's use equation 2. Okay, so we have 2a plus d equals 4. Okay, now we know the value of d to be 2. So we have 2a plus 2 equals 4. So we are going to transpose 2 to the right hand side. So we have 2a equals 4 minus 2, which is equal to 2. So we divide through by 2, and then we have the value of a to be 1. So the first term, that is a, is 1. Now from the question, we are interested in finding the sum of the fifth term and the sixth term. So let's find u5, that is the fifth term, and then u6, the sixth term, and then we can add them to find the sum. So that's what we are going to do. So we had the value of a, the first term, to be 1, and then we had the value of d, the common difference, to be 2. Now we want to find the sum of the fifth and sixth term. Now the fifth term is u5. So we have u5 equals a plus n minus 1 times d. Now we have a to be 1, and then we have n to be 5 because we are finding the fifth term, minus 1, and then we have d to be 2. So that is 1 plus, now 5 minus 1 is 4, and then 4 times 2 is 8. So we have u5 equals 1 plus 8, which is 9. So u5 is equal to 9. And then for u6, we have u6 equals a plus n minus 1 times d. We have a to be 1 plus 6 minus 1 times 2, d is equal to 2. And then we have 1 plus, now 6 minus 1 is 5. 5 times 2 is 10. So 1 plus 10 is 11. So U6 is equal to 11. Now we want to find the sum of the 5th and the 6th term. So the sum of the 5th and the 6th term is equal to U5 plus U6. Now we have U5 to be 9, and then we have U6 to be 11. So 9 plus 11 is equal to 20. So the sum of the 5th and 6th term is equal to 20. So that's it for today's video. Thanks for watching, and see you in my next video. In the next video, we are going to solve questions on application of AP. Bye bye.